This is Team Unsinkable's concrete canoe for the freshman engineering design project. In this video, we will cover the process our team went through in order to design our record-breaking canoe through the process of the engineering design cycle. Step 1 of the engineering design cycle was to identify the challenge. Our team was challenged to make a canoe out of concrete that held the most weight possible without sinking. Our canoe was then put up against other teams' canoes in a contest to see whose canoe could hold the most weight. Step 2 was to assemble the Dream Design Team. Our team consisted of software semi-expert Rio Brewer, chief brainstormer Charleston High, design head Colin Foster, creativity master Brian Vogel, and the guy who is good at building things, Caleb Hicks. Step 3 of the engineering design cycle was to identify the problem's specific rules and regulations. The canoe had to be canoe-shaped, and the length, width, and depth of the canoe must fit within certain dimensions. The canoe must also be sanded smooth. Step 4 of the engineering design cycle was to search for solutions. We researched what makes canoes strong and applied what we learned to a buoyancy equation to prove on paper that a concrete canoe could float. Next, we studied the actual makeup of concrete to try and assess how we could change the material to improve our design. We landed on the idea that replacing the coarse aggregate in the concrete would lighten the canoe without compromising much of its strength. This took hours and hours of brainstorming. In the engineering design cycle, steps 5 through 8 are repeated through several designs until a finalized design is complete. After analyzing several potential solutions, we drew up our design and then gathered our materials. During the week or so while we gathered materials, we tweaked the design because we found that a larger canoe would create more buoyancy force per amount of concrete used, and so we made our canoe as large as the dimensions would allow. Our final design did not change the actual canoe, but we found that our previous mold idea was too complicated and a simpler design was needed in order to quicken the building process. Once we had finalized our design, we got to work building our canoe. Once our concrete mix was made, substituting coarse aggregate for styrofoam pellets, we packed the concrete onto our mold and then later coated the outside of the canoe with silicone sealant. Before we show our results, let's go over what we learned. In this project, we acted as a better functioning team than previous high school projects. We also learned how combining the ideas of a team is more effective than any one person's ideas, and we learned how to use the engineering design cycle to solve our problems. Here is our works cited. The only last step was to test to see if it worked. Since we do not have film footage of testing the canoe, our footage is from the freshman engineering design day.